Salle.
Good morning, good evening, everyone. Welcome to the ongoing series of PAASE for Philippine Innovation, Fireside Chat series. I'm Gisela Concepcion. I'm a former PAASE president, and I'm a current executive member of the National Innovation Council. And we thought of hosting this series on behalf of PAASE together with my co-host, Dr. Alvin Colaba, to showcase the innovators that we have in our country, as well as other Filipinos based in other parts of the world. And this is to tell us that perhaps we have real seeds of innovation in our country that we could make a good use of and eventually showcase to investors, to MSMEs and larger industries for investment. Okay, we know that there are many challenges in moving an R&D project to the innovation and eventually the commercialization phase. But I understand that the different universities and institutions who serve as our stakeholders in innovation are trying to streamline the process and to make it easier to do the business of R&D and innovation, even as we know that we still have many problems relating to R&D, including procurement. But problems are not just on procurement. There are many other challenges. And as a scientific community, I think we should all work together to address innovations that are needed in all sectors of development of our country. And a very, very important area of development is agriculture, livestock, poultry, and the fisheries and aquaculture sectors, because very paramount in our country is to develop our food productivity and our food security in the context of climate change. And so today we have a very distinguished professor from De La Salle University. He is Dr. Elmer Dadios. And I welcome everyone to, at this point, still contact your colleagues to join us at this meeting, since we are only 13 participants. And I was hoping that the academics from DLSU would also be present. And so at this point, I hope that we can get more viewers. And I would like to give the honor of introducing our speaker to his colleague from DLSU, Dr. Alvin Culaba, whom we know is also a past president of PAASE. He is a current vice president of the National Academy of Science and Technology, also a past president of the NRCP, and a distinguished professor at De La Salle University. So the floor is yours, Dr. Alvin.
Thank you, Giselle. Thank you, everyone. Good morning and good evening for those in the other parts of the world. It's really an honor and pleasure to introduce our distinguished speaker for this particular Innovation Fireside Chat series this week. A close colleague and collaborator for more than 30 years now. No? He is a member of the National Academy of Science and Technology. He's our academician, Elmer Dadios. He is one of the highly distinguished professors at De La Salle University, professorial chairholder of Thomas J. Lee Chair in Manufacturing, Engineering, and Management, and the Victor T. Lu Chair in Production Management at our Gokongwei College of Engineering. He is a consultant on software and hardware development in the area of robotics and intelligent systems application. In fact, he is the chairman of the board of the Intelligent Systems Innovation Corporation. Currently, Academician Dadios is an editor and sits in various editorial boards of highly reputable international journals And his current research interests include robotics, mechatronics, applications of artificial intelligence to smart cities, smart farms, biomedical engineering, computational intelligence systems, and manufacturing processes. Ladies and gentlemen, Academician Elmer P. Dadios. Elmer, pare, the floor
Uh,
is yours.
Thank you so much, Alvin. Good morning, everyone, and a pleasant evening to all our friends in the United States and um, all over the world. So allow me to share my presentation. I hope you can see now the slides. Okay. First of all, I would like to thank our past president, uh, Academician Gisela Concepcion and Academician Alvin Colaba, for inviting me to be your speaker for today. Uh, the topic that I'm going to discuss is about machine vision and image processing technologies for aquatic research, capturing fish interactions with the environment. So, this research has been done through the Intelligence Systems Laboratory of the Salle University, which I happen to be the head of that laboratory. And particularly, I want to acknowledge my Smart Farm Research Group, my PhD student, former PhD student, Dr. Maria Jamel Palconet, and my MS student, Engineer Vincent Jan P. Almero. They are the one doing the hard work for this research. So this is the outline of my presentation. And as we all know, aquaculture is one of the major source of fish consumptions. And this help stabilize the populations of the wild fish since 1990s. And the challenge on aquaculture is the way how to feed the fish. 70% of the overall expenses for fish productions are goes to the food of the fish. Hence, we need to manage feeding the fish. So, danger are you might overfeed the fish or underfeed the fish. So, the problem when you do underfeeding is that the growth of the fish will slows down. They will become malnourished. And also danger of being overfeeding is that this is very costly. You buy the exist foods, which is just thrown away. And not only that, the quality of the water will be destroyed because those exist foods will be the contaminants. So we need really to manage that. So feeding mechanism nowadays has been done automatically, although the most important way now is hand feeding, wherein you need an expert to throw away this food for the fish. And the automated one are the time-based open loop and the on-demand. So of this automated feeding system, we are very much interested on demand because you need only to feed the fish while they are hungry. Okay, so this is very important. So my research focus on demand. There are challenges, by the way, on demand feeding system. One is the accurate real-time information, whether really the fish is hungry. So how do we know that? We need to know the behavior of the fish. So how does the fish interact with the environment through its motions, through the way he uh, uh, mingle with their co-fishes? So that is very important. And another one is the how to detect this. So we use sensors. And as you know, sensors are prone to false hunger behavior, there might be errors on these sensors. So the most really likely to follow the human way of feeding fish is the machine computer vision. So through the camera, this serves like an eye of a human expert that really can determine the behavior of the fish. So this is very challenging because we want to automate, we want to know really if the fish are hungry through its behavior. So we need to use a machine vision to do that. Now, just literature reviews, these are the automated fish feeding mechanisms. And by the way, they are on the shelves already. These are commercialized already. We have a trigger rod, but there are advantages of this. There is no monitoring history recorded. And then this is prone to false trigger, like because this bucket will open once the fish touches this rod. And sometimes fish just play around. They can touch this one, and in reality they are not hungry, so they are not going to eat the foods. So this is not really an accurate way. And also we have gyroscope, wherein through the vibrations of the water, we know that because the motions of the fish when they are hungry are unruly, so there's a lot of vibrations of the water, so this gyroscope can sense on that. But still, it's not the real meaning whether the fish moves faster because they are hungry or not. Okay. And also, we have the photoelectric sensors. As you know, sensors really are prone to errors because you have to calibrate the settings of the sensors. So still, there has a problem on this. So to summarize with, these are the very important problem that we need to address. So accuracy for detection and recognition, and then real-time response, and of course the optimization of feeding. So we need to manage that. So it is the direction of this research to design and develop an on-demand intelligent fish feeding machine for optimized autonomous operation for feeding management system and a recirculating aquaculture system. I use recirculating because this is inland, no? So the goal really, we have this feed description, whether we have overfeed, enough feed, underfeed, and efficient feed. So we are very much interested in this. So this will cause high growth rates and reduce feed cost. So the aim of this work really is to optimize feed distribution and keep feed loss to the environment at a minimum level. It means that we need to protect the environment. Okay. So what are the features? We have the fish behavior. This is very important because we will through the feeds, based on the behavior of the fish. So how does the fish respond to the delivery of food? And of course, what are the activities of the fish? And with that, we need computer vision, we need sensors, we need Internet of Things, and of course, the artificial intelligence algorithm. So by these are the enabling technologies. And to do that, we have to protect the environment already. So we need to have, if you are going to determine the pH level, dissolved oxygen, turbidity, temperature, electrical conductivity, dissolved solid, and what are the chemicals that found on the environment, like ammonia, nitrate, and nitrate. So this is very important. That's why we need technologies really to manage the whole system. So feed efficiency, of course, we know that the growth of the feed depends on this feed. So we have this curve here. You have to make body weight against the feeds of the amount of feed. So that is how to control it. And then Water quality, as I mentioned, we have to test all those parameters. Okay. So the challenge really is how to know that the fish is hungry. Okay. And so I mentioned about behavior. And so I mentioned about using machine vision and integrate this with sensors. So machine vision alone is not enough. In other words, we need to know the other parameters to trigger on feeding the fish. So we need to integrate this one. That's why Internet of Things. And this is the essence of the fourth industrial revolution. Monitoring of the quality of the water. Again, we need sensors of that. And then feeding fish machines. Of course, we can follow the existing feeding mechanism wherein there is a trigger for the fish to touch such that it will just throw away the food. But not only that, we need an artificial intelligence because, as I mentioned, fishes just play around. It might be that they're just touching this because accidentally. So we need a high level intelligence to know that okay, these are motions which are not hungry. Okay, so that is very important. And these are the important things. We need a camera. So put that one on top of the these are the one observing the fish. What are the motions of the fish? It can be on top and it can be underwater also. So as a result of this, we have made a prototype initially. It is just on a small pond, just to showcase, just to prove that our idea is correct. So this is the camera here, and there are sensors here, and of course the fish are cultured here. Okay. So with that, we are focusing on high level artificial intelligence algorithms. So we use algorithms like fuzzy logic and of course another deep learning to really understand the behavior of the fish. So you can see here the hardware assembly of the sensors. Okay. And then we had tested all those sensors. We had tested all those algorithms we have. So it can be seen that it is very accurate and reliable and robust. So this is the development on demand feeding machines. These are, as I mentioned, prototype samples. And then we tested all of that and we found that it's really robust. And we collect data. That's very important because when you are a farmer, when you are the owner of the aquaculture farm, you need informations. So data acquisition is very important. That's why aside from those machine vision sensors, you need a mechanism wherein you can transport, you can collect those informations regarding the behavior of the fish, regarding the size of the fish, the growth of the fish, regarding the amount of foods you give that one. So it is part of the things that you have to integrate into the system, the data collection. So you can analyze those those informations. You can say that okay, the feed are exceeded already based on these parameters. So the fish has reached to its grown stage because of these parameters, and that is very important. Okay, so to really understand the behavior of the fish, you need to train your system. Okay, so you train it through the motions of the fish. So you capture the images of the fish, you capture the videos of the fish, and put that one into your system as a ground truth of your system. Okay. So this is how we trained our system. We have this complete set, no? with sensors, with camera, and of course the uh, data acquisitions. Okay. And these are samples of the results of our systems. Okay. So with this information, we can generate a dashboard. You can make a real monitoring system. It can be on a remote site. It can be on the fish pond near to that. But very important thing is, if you are the owner of this aquaculture farm, you can monitor your system 24/7. Sorry. So you can analyze the size of the fish. You can analyze for this month. This is the amount that we feed them. This is the size, and so on. So statistically, it's easier for you to manage the system. Okay. So these are samples. You can say that evaluation of fish weight and gain and FCR after 10 days. You can do that also after 20 days or after a month and so on. So you can dictate based on the dashboard that you have. Okay. So we do some evaluations. Of course, we tested what is the appropriate positions of the camera, what is the appropriate positions of the sensors. So all of this has been taken care of to ensure that the system developed is reliable and robust. Of course, accurate also. So in the environment level, our camera can see the motions of the fish, what is going on. We can analyze that, digitize the system, and feed that one to our data repository. So these are samples of motions of the fish wherein they are very active. This is where you can say that fish are really hungry. They congest on this side wherein you can put they're looking for the food. And then this is the video for fish wherein they are already full. They are not as active as they are hungry. So this behavior should be captured on the system, on the automated system, because this is the idea for the automated system to give food to the fish. So this is a picture before feeding, during feeding, and then after 30 minutes, they are on this behavior. After 1 hour, this is their behavior. After 4 hours, this is their behavior. So that is very important to know. Okay. And then a sample of raw data and a sample of digitized data. So this is how our image processing, our algorithm works. Okay. And of course, we can classify now the fish hunger behavior. So in other words, we can really strengthen our ground truth. So this is a dashboard monitoring system. Okay. And you can see here how does our real system work on real time. So this is our computer. With that, interacted on generating data on real time. They can get those informations right away based from the environment images, based on the conditions, based on the values of the sensors. So integrating those things is very important. That is why we can come up with this dashboard monitoring system. So this is a sample. For example, here we can put the fish feeding machine here. So the fish will congregate on one area asking for food. Okay, so it's very interesting. The fish has intelligence, by the way. When they are hungry, they just go here, knowing that this is the area for where they can get the food. So it is now automated. Okay, you can just let the fish come in, eat, and when they are fully fed, they will just go and relax. And that behavior is very important for our system to capture. Okay. So with all those things that we develop, statistically, we prove that our system is accurate. The processing time, this is very important because we can say that at 3.7 minutes, we can really know what is going on of our system. Okay, so what are the contributions to this? There is a technical benefit, there is socioeconomic impact, and of course the environmental welfare. And these are the very important things that we need to consider today. So as if you're doing smart aquaculture, it's not only that you just grow fish, but it must be on a collective way. You need sensors, you need computer vision, you need the artificial intelligence, and of course integrating this through Internet of Things. Okay. Now, as you can see, the major problem on this on-demand aquaculture system is the camera or the lack of visual information. So we tried lots of camera, even GoPro. We found out that the resolutions, the informations from those camera is not enough, especially when the water is turbid, when the environment is complex. So getting the real information is very hard. So we opted to create our own camera. My student developed camera system or construct a camera system using RPI. So this is one of the novelty of this research because we create our own. Okay. So as you can see, this is the architecture. There is the environment, and this is the Raspberry Pi point of power over internet. And then of course, the beauty here is it is on a remote site where we can see these images, meaning anywhere you can access the information from this camera through this cloud system. Okay, so this is the idea that we develop our own underwater camera. Okay, so this is the developed camera that we designed. Okay, so these are the hardware part of the system, and then from there we need to put this one on a very compact and waterproof system. So we fabricate the enclosures for that. So this is now the camera waterproofing system that we have. And then of course these are the specifications of the camera that we had. And then with those informations we can generate data, we can access data, get from directly from the camera acquisitions, video acquisitions. So these are the results. These are the real-time streaming within the area, and this is a remote real-time streaming, meaning I can go on my lab at Salle, and these farms can be somewhere else in Morong or where, at any real at any point of time I can access those information. Okay, so we can get this informations, whether turbid or fish pond. So this is the frame rate of the camera. So we tested this, and then data gathering. We these are the samples. You can put the system on a prototype, what they call the fish pond. Okay, so gathering those informations, and then these are samples. When we test the system, we get water from the fish pond and try to really look at what is the importance of this, what is the resolutions of this camera. We change the water turbidity based on the conditions of the fish pond. So we show that the result is very accurate and reliable and robust through this histogram. And then we can say that we the developed camera we had can be used right away. And so this is what happened here. Okay. So these are my team on the Smart Mat Farm. By the way, I started the Smart Farm Research Group because of the USAID Stride project that we have. I was granted this Smart Farm research. So from there, we evolved. It started on vertical farming, and then it goes to aquaculture farm. Okay, thank you so much, and I'm happy to entertain questions.
Thank you very much,
Thank you,
Dr.
Elmer.
Elmer Dadios. So we will be following the format of our fireside chat, which is that first, well, I would like to welcome and recognize the presence of a very important participant today. It is a former DOST Secretary Fortunato de la Peña. Dr. de la Peña, welcome. Thank you for letting me know that you are joining us today. And we have many other participants here who are stalwarts of PAASE, whom I'm sure will ask questions after I and Alvin ask our questions. So congratulations, Elmer, for your very impressive work. I have 2 questions, but many more. I will just limit them to 2. And one is the level of urea. So urea, as we know, at sublethal concentrations, really reduces the growth rate of fish. Okay, my second question is, this is more from a human standpoint. So hunger pangs in humans is not necessarily an indicator of your nutritional needs. So we know that. So I imagine fish, who are our ancestors because we are chordates, might have the same, hormonal signals. So I'm just curious, when you do your algorithm, is there a hierarchical or weighting, weighting factor to give more importance to certain parameters that you're measuring? And would the hunger indicators be at the top or in the middle? And if you may permit me to ask a third question, are you thinking of producing some of your encasements of your sensors? I imagine your sensors are still imported, but are you doing the 3D printing of your encasements and all this? Because we are all moving towards trying to get the system locally made. But of course, that's not yet possible. So I have those 3 questions, and quick answers would be good. Thank you.
Okay, thank you, Giselle, for that very nice and interesting question. First is the urea. Well, as I mentioned, we always prioritize the environment. So our sensors will really take care of that, looking at the chemical compositions of the water. So that is very important. And every time we check it and it's not good, then the water should be replaced or whatever actions that you can make. Second, about the behavior of the fish, okay, in terms of eating, in terms of how the growth. Remember, I showed to you a graph wherein we are calibrating the growth rate based on the days and based on the food that we give to them. And that is how we monitor that one. We have to ensure that at this month, the growth should be, the weight of the fish should be at this level. So that is very constant a process. I mean, a routine process for that. We can monitor right away. So we prove that, okay, through this feeding mechanism, through these behavioral systems, we optimize the growth of the fish. That is very important. Thank you.
Third question about, manufacturing
yes, that one. That is very important. I'm happy that Sir Boy is here. I'm very fan of Sir Boy. During his time, he helped. He helps a lot of my research. Well, yes, that's the ultimate goal, to make our own. As of now, I showed already that we make a prototype. That is our own. Okay, so to mass produce that one is very important. I think DOST can help us on that, or any agency can help us to mass produce that system. Thank you.
Thank you. All right, I'll hand over, the floor to Alvin for his questions, and then we will open the floor. I see
Yes.
a lot of hands raised. Thank you.
Okay. Thank you. Thank you very much, Giselle, and thank you, Elmer. Excellent work with the team. No? Elmer, my understanding, that your environment is an ambient, open environment where your fish actually grow. No? But we know very well in this situation, we have so many factors that could affect the environmental conditions that may affect, of course, the life of your fish or the growth of your fish. Now, can you design this in a more controlled environment, or an indoor, for example, environment, and you would still yield the same growth of your fish? So that, of course, we are looking at the climatic, protection or changes in our, extreme weather conditions. So could you design this in a more controlled environment, in an indoor, environment? Is this something which would probably similar in terms of the application of the technology that you have, Elmer?
It's bump off po. He's trying to log in again.
Okay. All right. So it should be coming back soon.
All right. So
Yeah. Meantime, are there
Yeah.
questions?
yeah, I think Al has his hand raised, but we'd also like to give the
Okay.
floor to Sec Boy, and then we'd like to recognize the presence of our EVSU officials, Alvin. So Dr. Dan Pulma is here, and others from EVSU. So Al, maybe you can ask your question now.
But Elmer is he
Elmer's
here now?
not here.
Is he back?
Elmer back?
Wala pa yata
Si
si Elmer.
Elmer. Tatanungin natin.
Because Elmer
Pero-
is driving, I think.
Oo
No,
nga.
but I'll compliment Elmer na lang muna for the rest of the audience. Clearly,
Ah,
Elmer
sige.
He's back.
has evolved from actually our first project with him was the automated coconut sap
USAID.
concentrator,
Yeah.
USAID,
I thought we
9
talk
years
about
ago.
that I like
9 years
to know
ago.
Because I was lost for a while.
Yeah, and then he moved to traffic control. So now he's watching fish. So talagang magaling to si Elmer. So, but really, to me, my interest, Elmer, is your foray to Industry 4.0, because we just surveyed, both Alvin and I were in Mindanao last year, looking at Coronadal, Davao, and Cagayan de Oro for adoption of Industry 4.0 together with Larry Degal of UP Mindanao. And clearly, the adoption at that point of Industry 4.0, like what you're advocating now, is next to none. Let's put it be frank. And we also just recently did a 500 company survey for advanced manufacturing in the Philippines. And we have 230 respondents. And most of the adoption of Industry 4.0 are focused on cybersecurity and supply chain. And only 15% of those companies that were surveyed have actual Industry 4.0 adoption. So for me, my track right now is really to find ways to get samples or models of Industry 4.0. And I think the most likable, at least in your development, and not to simplify your methodology, I like that you're trying to attempt not only visual as well as chemical analysis, but really talking to the customers eventually. We are planning to go together to General Santos, and I'm already visualizing going to Sarangani Bay of the Alcantaras and look at how we can help them with your offering. We have 350 hectares of bagus plantations of fish pans there that I've visited before, but really finding a way where we can gradually introduce IR4, Industry 4.0, maybe a simple IoT measuring indeed what Giselle said, urea, what is their biggest problem in terms of higher mortality. If we can identify that, focus on that initial problem, Same way we were focusing on drip irrigation on their 350-hectare plantation of bananas, looking at moisture content of the soil using drones and figuring out where to turn on the water. It can be as simple as that single parameter, but well done right and reduce cost or increase productivity in the field. That's my challenge to you, because indeed you've looked at quite a bit of the complexity of the technology, but for me, I like to keep things simple, and prove that we can indeed develop a IR4 technology that can increase not only efficiencies but productivity and economic viability of this aquaculture
So
project.
it
Thank
looks like Elmer
Is
has to
Elmer?
answer 2 questions. Alvin, stay
Elmer
in
is
house.
still there. I'm Elmer.
Yeah,
Yeah.
I'm here. Sorry,
Ah,
guys.
okay, Elmer.
My internet just got lost. I'm back now.
Okay. I actually I'll just relate this now to the recent question of Academician Serafika. Earlier, Elmer, I was actually asking about the possibility of adapting your technology in a more controlled environment, in a close, primarily to address the climatic changes, which probably is sensitive to to the conditions at which fish actually grows. And I think this is connected now to Al's question earlier, that I think if we want the fourth industrial revolution to be or advanced technology embraced by our farmers to some technology, then I think if we can relate that to the impacts, sometimes they don't have a choice, no, because of the, like for example in Leyte, where we are visited most of the time by these strong rains or typhoons, and therefore having a more controlled environment. And it's only through this technology that it can actually be adaptable. So what is your view on this, Elmer? And are you going in that direction, in your technology development? Thank you.
Thank you so
I will
much.
only have one question.
Okay.
Go
Okay.
ahead, Elmer.
Okay, thank you so much for that question, Alvin. Yes, exactly. That's what we really aim for our research, to use this one on a commercial scale, and to help the farmers also, the aquaculture group. I am talking to some also, even emission awan there on fisheries. I remembered also I was one of their speaker, and they are very interested on that. So yes, again, it boils down how to make it commercialized. That's the challenge, and hopefully we can through all we can connect to the potential investors. So we are happy to do that. We're really happy to do that.
Okay. So thank
Giselle,
you.
I will defer my second question,
Yes,
because
I
I know
think
there are many who wants
in an
to ask
indirect
questions.
way,
Thank you.
Al's question was answered. I see Joel Cuellar's hand raised. Joel, and then afterwards Benji Vallejo. Okay.
Yes, thank you, and good evening to everyone from Arizona. Elmer, congratulations on this project. I really like it. I think it's quite brilliant. And it's very important that you and your team developed your own original camera that's able to see through different turbidity levels of the water. I think that's really important. If you've not already done so, I think you should consider patenting that camera. But my question and suggestion here is that I think it's really great that you are monitoring the behavior of the fish to kind of gauge their level of hunger. And then that's the time that you turn on the feeding machine or equipment to feed them. But as you know, over time, the fish will grow. They start small and then they grow. And of course, one way of monitoring that would be the weight of the fish. But I don't think that there's a direct way to really monitor the weight of the fish. So I'd like to suggest that with your camera, you then will be able to do measurements of the dimensions of the fish over time. And independently, you can do a correlation between the dimensions of the fish and the actual weight of the fish. And you can incorporate that into your intelligence system so that over time, you can actually monitor the weight of the fish. But it's not just the weight, but the change of weight over time. And I think that's a very important information because you will know when the fish is actually gaining weight at an accelerated period of time. And during that time, you have to put more feed into the water. You don't feed them the same amount over the entire time period. So that would make your system really much more accurate, and that will directly address the need of the fish. And at the same time, by doing that, you are not decreasing the efficiency of your feeding rate. So anyway, I'm just sharing those to you for your consideration, but comments, please. What do you think?
Yeah, that is very excellent suggestion, Joel. Actually, that's really the next phase of this.
Yeah.
By the way, as far as the size and weight of the fish, I did that one already sometime in
Okay, great.
late 1990s because one of my undergraduate students, I am the thesis advisor, has a canning factory somewhere in Zamboanga. So the
All right.
tuna fish sorter we have
Yes.
is based on the camera. We can
Yes.
relate the vision, the image
Yes.
to the weight, because at that time they use this conveying system. It is very difficult for them to weigh because
Right.
the sensors for the weighing machine is vibrating. So
That's right.
we opted to use a camera to look at
Yes.
the. It's so good that a tuna fish body is homogeneous. So even
Right. Right.
on top part, we can generalize that this is the size of the fish for that type of weight. So
Yeah.
we use neural networks at that time, and
Yeah.
in late 1990s, we have already that kind of.
Right.
I published that one also. So
So you can apply that to this one and incorporate.
yes.
Yes.
But the idea you made, relate that one from time to time, that is
Yeah.
excellent.
Yes.
Get the statistics of that. That is very
Right. Because this is clearly a function of time. Yeah.
yes.
Wonderful.
Thank you, Elmer.
So
Thank you.
I think Elmer is a leader in not just in aquaculture development, but also in open fisheries, in the case of tuna, right? So I'd like, before I call Ben G. Vallejo, I'd like to recognize the presence of academicians here, Gil Jacinto, Sean Raimundo, and then, corresponding member Ed Mendoza. And we already know that Joel and of course Al are here, and corresponding member Vic Ilag. So I think key people are here at our meeting today. And so now I would like to call Benji Vallejo for his question. Benji, are you still there?
You're muted, Ben.
Muted si Ben.
Okay. Sorry about that. Okay, good morning and good evening to people on the other side of the world. I think the presentation could have been presented at the last week's international conference on fishery and aquatic sciences at UP Visayas, no, in which I think somebody mentioned there was a poster about using AI in aquaculture. I remember it. I was there last week. But I'm going to ask a question wearing my fisheries hat because I am a fisheries major, really. uh, because there's so many fish with different trophic levels, different behaviors. Can the system account for that? Let's say if we're going to come up with a commercial application for this, could it be adapted to different aquaculture species? For instance, could it be adapted to crustaceans or more carnivorous high-end fishery products like lapu-lapu, and on the lower end bangus and tilapia? Can the AI system be able to learn the trophic differences so it will make feeding more efficient and cost effective?
Okay, that's a very good question, Ben. Yes, my answer is AI can use that one. In fact, one of my PhD advisee use shrimp prawns. So as you know, the environment of the prawn is very critical. They need a cool environment. So we developed that one already. Prior to this project, I had a PhD student whose research is on prawn culture. So yes, but you have to take note all of these species have different characteristics. So your algorithm must be specific to that characteristic also. It's very difficult to generalize one algorithm for every for all species. So it is subject to the domain of that particular fish. We can do that.
That's good to hear. Thank you.
Thank you. We have a question from Ralph Turingan, but before I call Ralph, I'd like to advise Elmer to file your intellectual property protection at this point. You might be aware that UP, through the invention of UPMSI and computer science, they just got an international patent for fish eye, which is also, you know, AI driven. It's also sensor based, and it's to monitor fish population and density. Okay. Anyways, that is more related, I think, to biodiversity conservation. This is major applications to industries. Elmer, very valuable work that you're doing. So at this point, I'd like to call Ralph Turingan, who gave us his fantastic talk about 2 weeks ago on aquaculture as well. Thank you.
You're
Unmute, Ralph. Please unmute yourself.
Sorry about that. My commendation, a very impressive presentation, Elmer. I just have a couple of questions, and I'll email you with some more. I noticed that in your homemade camera, maybe I missed it. The capture rate is 7 frames per second. Is that correct?
Yes, it depends on the distance, Rob. There is a distance of the object. So if you look at the matrix, the table there, for this distance, this is the one. For this distance, this is the one.
Yeah, so in that regard, if that is 7 frames per second, you may, I think you may want to increase that because you may miss a lot of behaviors in between. That's I think in my experience, very slow. So maybe you can look at optimizing capture rate so that the sensor can actually fine tune it to how much of the behavior of fish is captured per second. But there is a more practical question I'd like for you to address. I noticed that the most important benefit of your system is to determine when feeding is appropriately conducted, right? So that's the timing, when feed is released. But how much feed is released per feeding time would probably be as important as the timing of feeding, don't you think? How much of the feeds are released per feeding time? Yeah, depending on as I think Dr. Well had mentioned, as a factor of size, aggressiveness, hunger rate, and things like that.
Okay, at the moment, we base on what we see on the environment. So it means that what we have to monitor. Does the fish still eating? So we can see that. Does the fish motions tuned for hunger? So these are integrated behavioral systems of the fish. So the opening of the valve depends on that. It doesn't mean it's not time-based. That's why it is adaptive. Okay. Right. So if the fish still are eating, then we still open the valve. But they are moving, but they are not eating. you have to close the valve. So these are parameters that really not exclusive of time, meaning behavior based. The opening is based on the behavior, based on the presence of pellets on the water, based on the eating habits of the fish, whether there are voracious one or they're just a simple, similar to the way that we look at. They are very hungry, they are moderately hungry, they are not hungry at all. So the algorithm drives with that.
Truly smart. Thank you.
It looks like a potential collaboration,
Yes, yes.
close interaction between Ralph and Elmer. And I can imagine
hey,
the kind of feed, the feed
thank you so
form
much.
would matter so much as
Yeah.
well, you know, the form of the feed. Anyway, I'm reading some comments and the questions here from the chat box from Academician Sean Raimundo. Impressive system, Acad Elmer, but of course it would cost quite a bit. Can this be something that small fishermen can adopt in a cooperative system so they can share the cost? Another comment, aquaculture is a more controlled environment, you know that. But curious how you would control light and dark and temperature. Fish are so sensitive to these factors. That's from me, okay? And then here is from Joel, comment, Elmer's innovative technology is crucially important because there is a critical need for the Philippines to expand its aquaculture industry in view of climate change and mitigate, avert natural waste degradation. What's more, aquaculture is fully scalable and lends itself to effective environmental management and protection. Aquaculture is also a good vehicle for growing high-value fish for local consumption and export. Well, I'd like to say, Joel, that we missed you last Friday because we had smart greenhouse agriculture that can grow 30 high-value crops. And this is already being adopted by Gawad Kalinga Seed Academy together with Quezon City University. And also, well, the technology comes from Taiwan. It's from the AgriGaia Social Enterprise. So anyway, you might want to answer some of these questions. Elmer, at least the first two.
Well, I think if you took on implementing this to a small or cooperative, that's the best, no? Because we can distribute the cost, and I mean, it is not really expensive to do this. By the way, it's not really expensive. The camera, as I mentioned, this is a low-cost camera. The feeding machine, we can fabricate that one. I don't think this is very expensive thing.
Thank you. That's very promising. If cooperatives, you know, the leaders can be trained, you know, with this, I think training is very important. That's the other component, Elmer. We cannot forget the importance of this. I was at a meeting the other day of a group that was commissioned by the NEDA, NIC, to do the analysis on barriers to innovation aside from procurement. And one of the ladies who had done apps for government agencies said they did a good app, and in the end, the government agencies decided to drop it. Why? Because they could not train their manpower, their employees to use the technology. So it's the same thing. We know the problem in cooperatives that many of the equipment that DOST and the other agencies had distributed to them during the time of Pinoy and before that had been wasted, nangalawang na lang kasi walang marunong gumamit, walang nagtuturo ng paggagamit sa mga farmers. So the next question, Elmer, is the one on, you know, light and dark. You know, it's the nocturnal thing. And I know that CM Eddie Mendoza is so much into this type of studies, you know, the influence of light and dark, and also, of course, temperature. So those are monitored, especially during, you know, climate change threats. Nagbabago din yun, diba? Naaapektuhan din ang aquaculture systems. Hindi lang yung open water systems, of course, no?
Yeah, actually, that's the major challenge really underwater, because the environment is really changing from time to time, the turbidity. So the camera that should be used is capable of infrared, capable of looking the dark. So as technologies progresses, really we can improve that one. Right now, I say this needs further improvement, but although we can use it, but it really is subject to more innovations, more research to do. Yeah.
Ang sabi ni Joel, scalable, totoo yan, no? So itong iyong prototype, how big is it? Anong dimensions niya for now?
Actually, I'm happy to see Joel is here. Actually, we can do similar to vertical farming. We can do aquaculture in your house. Just like remember, we have lot of what you call that one, fish in your house. You have an aquarium. We can use aquarium to do this. So in your house, you can make this culture. I mean, it can be done.
Ang sakit ng mga aquarium sa bahay, yung algae. Before
Yes,
you know,
yes.
no, hindi tama yung circulation. But anyway, Ralph is here, and you are here, and you can really solve these problems. And we also have experts in MSI to do this, as well as in UP Visayas. But Ralph is here. And it's true, it's really scalable down to the homes. If you think of self-sufficiency in food, actually in Taiwan, all over Taiwan, you already have commercial units for sale na parang talagang pang vertical farming, pambahay, Joel. It's really, got a market, no? Because if you think about it, you can really grow your own veggies aside from the companies growing them in their buildings, no? So, but I'm talking about larger scale aquaculture farms. Elmer, some of them we know are kind of on the coastal. So on the other hand, yung mga iba naman talagang as you parang modeled, nakasemento yung yung encasement, no? So can you tell us a little bit more about those two systems? And for the coastal types, well, that's another consideration, and we need to think of how they can be incorporated in our coasts in a way that we will not threaten our, the coastal covers or the green belts that we want to grow on our coast to protect us from the storms, from the storm surges.
All right. For big ponds, for example, I've seen a lot of big ponds in General Santos. Even MSU has a farm, fishing farms also. I've been when I was in college in MSU, most of my friends are doing fisheries also. They have this big ponds wherein when you feed that one, an expert just go to one area and throw the feeds. We can make our system on the sides of the pond, and if it is so big, we can put a system on another side. Okay. In other words, for a one big pond, we can put 4 systems there, wherein fish can go there and just eat, because the fish, as I mentioned, has intelligence also. When they know that this is the area where they can find the food, they will just go there. They will because they look for food and they know the area that this has plenty of food always. So from that behavior, we can put systems on that area. So I don't think there's a problem for big farms.
So you seem to have answered already the question of the ilag in the chat box. Are you considering to apply this to the open sea, like for tuna or cobia ranching? And my comment about this, and I also had this in mind, is pagka open sea na kasi, Elmer, ang hirap talaga rin ng wind and current. Okay? Yung factor ng wind and current, water current, and then what its impact would be nga on your cameras or your sensors. Kasi baka masyadong malakas ang noise, no? So anyways, before you answer the question, Joel's comment is indeed Elmer's system would work seamlessly in a hydroponic and aquaculture equals aquaponic system. I have seen small models of this, Joel, and this is again perfectly scalable. So mukhang talagang amongst us, meron tayong affirmation of how to move forward, no? So this is really great. and there is experience not just from the marine and aqua systems, but also from the terrestrial systems. So yes, Elmer.
Yeah, about the open seas, I'm not confident on that. I have not thought of that to work with yet, because as you mentioned, winds and waves, and when there are typhoons, it's very disastrous. Yeah. So I have not think of that yet.
So controlled systems muna, encased aquaculture systems. So I think that's a very great start. And you're right, Alice, right? Among the many that they have surveyed, there could be a few industries that would be interested in this. And our job at the NIC is to match you to them. So at this point, maybe we would like to hear from our dear former Secretary DOST Boy de la Peña, who might have a few words of wisdom to share with us. Dr. de la Peña.
Nandiyan pa ba si Sakboy?
Nandito pa pero nakamute. Nakamute si Sir Boy.
Okay. Sige.
Okay.
Meantime. Hello?
Yes, Alvin.
Yeah, meantime, while waiting for Sakboy, maybe Elmer really to introduce the design, really to address climate, resiliency, because many of our areas in the provinces or many areas in the country are really vulnerable to these impacts of climate change. So any use of this technology, to develop resilient, systems would be very, it's an alternative, to many of our farmers who you would usually lose a lot of money, or the productivity really, lowers very much when this bad weather or these situations actually arrive. So maybe just a suggestion, Elmer, if we focus on building resilient, systems that can be utilized in highly vulnerable, areas in the country. Thank you.
Alvin, I think it's really time for Elmer to do some kind of a business plan for this, assuming a certain scale. Kasi talagang dapat na to, kung may prototype na, talagang pwede nang ipresenta sa industry, tapos sila na talaga ang pwede siguro mag-scale up. Okay? So mukhang wala
Giselle, this kind of ideas, is this something which the National Innovation Grant would be able to support?
Absolutely. Kaya, well, if we have already entertained everybody's questions and wala nang mga comments, we could move on to the next part, where I will explain what we are trying to do, well, with many great challenges, of course, to help you, our innovators, no? And I just have to say that I think I have another meeting with Vic Ilag at 10 o'clock because, well, I am really, I think I have found more funding for him from the National Development Company, okay, which is a GOCC. So we have a meeting at 10 o'clock. So may I then ask Feb to just, post our poster for next, look at this one first, to just get us excited about our speakers next week. Is Ran Quijano, friend of Vic Ilag, who will talk about agritectura. So we know that our most urgent concern in the country is really food security and productivity. And so we have to address terrestrial and aqua and marine sources. So that's Francis Ran Quijano. Okay, he's already a tech company. It's working. And then after that, we're going to have Joyce Ibana, our very own Joyce Ibana of Institute of Biology. And I can't read the title, but she has many innovative projects. And one is, of course, on probiotics. Okay, gut for you, GUT for you. And then after that, we were going to have none other than the newly elected UP Manila Chancellor, Michael T., who's an MD and an MBA. And he's also a data science and AI person. So he's going to talk to us about some simulation models for teaching and learning in PGH and the UP College of Medicine. And then our fourth speaker in November would be Joey Ocon, whom we know already has formed a company on batteries. And his company has as his major investor, businessman, Mr. Charles, and the name of the company is Nascent Incorporated. So we have this for November, and then we also have for December. We have 3 speakers for December. Okay, I won't tell you anymore who they are, but I'm hoping that Joel will speak sometime in February because our January is also full already. Anyway, I just like to let you know that well, we are really working on the new grant proposals for the National Innovation Council. It's nothing like the funding from the DOST that's available these days, especially from the VIP. Okay, lots of money there. As Homer Pantua, one of our innovators who set up a successful business here, BioAssets, says it's bigger than the R1 grants in the United States. What the money available is bigger. Anyway, for the grant proposal, in the rounds of call for proposals in 2024, it will be kind of a self-liquidating, must be self-liquidating proposal. Of course, that's still very, very flexible. An ROI could be small and it could be over several years. But I think that what we will want to do is to try to fish out all the innovators. I myself will go through all our speakers, and I would like to be able to invite some of us, our speakers, to write proposals. And then we will find ways to connect you with the prospective investors that Al could help us with. But also we have our own list, I think, at the NEDA, at the NIC, of potential investors in the right priority areas, because the NIC has 10 priority areas, and food security, of course, is tops of them. No, okay. And then again, there is a form that we have available in our website for anybody who wants to submit a position paper. I understand there was a position paper that some of us were thinking of on STEM education, and I thought that it would be submitted to Senator William Gatchalian, and the NIC executive members are having a meeting with him in December. But PAASE is free to submit this through the NIC or directly to Senator Win. Okay, barriers to innovation and proposed solutions. So NEDA commissioned a group, Primex, a private consultancy group that has consultancies all over the world. And we had a meeting last Thursday, last week. And there was like the first level of analysis of what these barriers are, aside from procurement, which is a separate topic. But I think that it could be deepened, the analysis could be deepened per sector, per priority area. I'm sorry about this. So anyways, I think we're reaching the end of our event, and I would like to thank everyone for being here. Most of all, I'd like to thank Elmer for sharing your knowledge and know-how, your wisdom, which I've appreciated in the last 20, 30 years since I first met you when we were campaigning for the PAASE, National Science Complex. And so I'm so happy that you're newly elected in the National Academy of Science and Technology. I think it is long overdue. So anyways, I think that Alvin would have the last word on this today. Thank you.
Yeah, thank you again, Giselle. We always appreciate the presence of many of our, audience. But I really want to encourage those in the provinces I know you are always, wanting to hear these ideas, but I think it's important that you have to communicate this to us as well. Maybe in the next series of our Fireside Chats, you can really speak and then tell us what you have, what problems do you have, and how these technologies can be applied to you, on how these innovators can collaborate with you. I think this is the most important and the intent of this series of Fireside Chats. So we look forward again in our next week's Fireside Chat, and we hope that there will really be something, actions on the ground that should benefit, the communities and the people throughout the country. So once again, we thank everyone. Of course, PAASE, I think we have here our PAASE officials, Marge Peña. I do not know whether the president, Mario, is here, and Vice President Gladys, and other members of the board of PAASE, like Al, is here. So we look forward to another week next week and the subsequent weeks in November and December. So hope to see you again soon. Stay safe and healthy, everyone. Bye-bye.
Just to remind everyone, the recordings of all our PAASE for Philippine Innovation Fireside Chats, they're available on our website. So if you were not able to attend, or your friends could not make it, just let them know that you can watch the clean version of the recording from our website. Thank you. You could even use them in your courses. You could use them in Science, Society, and Technology, Benji. Okay, you can use them in your courses. It's open.
Yeah, we can use it in our courses.
Yes. All right. So
Yep.
we're
Thank you.
going to end our event today. Thank you so much, everyone.
Thank you.
Bye-bye.
Thank you. Elmer, thank you very much. Okay. Ingat kayo dyan.
I love the complexity. Elmer, talagang nothing is simple. Kaya lahat talagang kailangan